In electronics, emitter-coupled logic is a high-speed integrated circuit bipolar transistor logic family. ECL uses an overdriven BJT differential amplifier with single-ended input and limited emitter current to avoid the saturated region of operation and its slow turn-off behavior. As the current is steered between two legs of an emitter-coupled pair, ECL is sometimes called current steering logic, current mode logic or current switch emitter-follower logic. In ECL, the transistors are never in saturation, the input-output voltages have a small swing, the input's impedance is high and the output resistance is low. As a result, the transistors change states quickly, gate delays are low, and the fanout capability is high. In addition, the essentially constant current draw of the differential amplifiers minimises delays and glitches due to supply line inductance and capacitance, and the complementary outputs decrease the propagation time of the whole circuit by reducing inverter count. ECL's major disadvantage is that each gate continuously draws current, which means it requires significantly more power than those of other logic families, especially when quiescent. The equivalent of emitter-coupled logic made out of FETs is called source-coupled logic. A variation of ECL in which all signal paths and gate inputs are differential is known as differential current switch logic. History: ECL was invented in August 1956 at IBM by Hannon S. York. Originally called current steering logic, it was used in the Stretch, IBM 7090, and IBM 7094 computers. The logic was also called a current mode circuit. It is also used to make the ASLT circuits in the IBM 360/91. York's current switch, also known as ECL, was a differential amplifier, and the input logic levels were different from the output logic levels. In current mode operation, however, the output signal consists of voltage levels which vary about a reference level different from the input reference level. In York's design, the two logic reference levels differed by 3 volts. Consequently, 2 complementary versions were used, an NPN version and a PNP version. The NPN output could drive PNP inputs, and vice versa. The disadvantages are that more different power supply voltages are needed, and both PNP and NPN transistors are required. Instead of alternating NPN and PNP stages, another coupling method employed Zener diodes and resistors to shift the output logic levels to be the same as the input logic levels. ECL circuits in the mid-1960s through the 1990s consisted of a differential amplifier input stage to perform logic, followed by an emitter-follower to drive outputs and shift the output voltages so they will be compatible with the inputs. Motorola introduced their first digital monolithic integrated circuit line, MECLI, in 1962. Motorola developed several improved series, with MECL2 in 1966, MECL3 in 1968 with 1 nanosecond gate propagation time and 300 MHz flip-flop toggle rates, and the 10,000 series in 1971. The high power consumption associated with ECL has meant that it has been used mainly when high speed is a vital requirement. Older high-end mainframe computers, such as the Enterprise System/9000 members of IBM's ESA/390 computer family, used ECL as did the Cray 1 and first-generation Amdahl mainframes. The DEC VAX 8000 computers used ECL. Implementation: ECL is based on an emitter-coupled pair, shaded red in the figure on the right. The left half of the pair consists of 2 parallel connected input transistors T1 and T2 implementing NOR logic. The base voltage of the right transistor T3 is held fixed by a reference voltage source, shaded light green, the voltage divider with the diode thermal compensation and sometimes a buffering emitter-follower. Thus the emitter voltages are kept relatively steady. As a result, the common emitter resistor RE acts nearly as a current source. The output voltages at the collector load resistors RC1 and RC3 are shifted and buffered to the inverting and non-inverting outputs by the emitter followers T4 and T5. The output emitter resistors RE4 and RE5 do not exist in all versions of ECL. In some cases 50I copyright line termination resistors connected between the bases of the input transistors and a 2V act as emitter resistors. Operation. The ECL circuit operation is considered below with assumption that the input voltage is applied to T1 base, while T2 input is unused or a logical zero is applied. During the transition, the core of the circuit the emitter-coupled pair acts as a differential amplifier with single-ended input. The long-tail current source sets the total current flowing through the two legs of the pair. The input voltage controls the current flowing through the transistors by sharing it between the two legs, steering it all to one side when not near the switching point. The gain is higher than at the end states and the circuit switches quickly. At low input voltage or at high input voltage the differential amplifier is overdriven. The one transistor is cut off and the other is in active linear region acting as a common emitter stage with emitter degeneration that takes all the current, starving the other cut-off transistor. The active transistor is loaded with a relatively high emitter resistance Re that introduces a significant negative feedback. To prevent saturation of the active transistor so that the diffusion time that slows the recovery from saturation will not be involved in the logic delay, the emitter and collector resistances are chosen such that at maximum input voltage some voltage is left across the transistor. The residual gain is low K equals a C Re.